No, this class is about examples of conservation of energy in electric field. Let's solve example number 1. You have an alpha particle here, and from the alpha particle at a distance of 20 nanometer, you have a point P. Then you have another point Q, in fact S, and the distance of S from the alpha particle is, for example, this distance is 30 nanometer. The question here is, the A part of the question is calculate फादो मुझे कैलकुलेटर उठा के दे दो कैलकुलेट VP and VS. Calculate VP and VS. First question is about calculation of VP and VS. Now, before moving on, you should know that the charge of alpha particle will be, alpha particle is basically with numbers 2 and 4 is, as you see, helium nucleus. And when you are given with some nucleus, its charge and mass can be written as, for example, for alpha particle, the smaller number, this number will be the charge, and the higher number, this number will be the mass. But the units that we use for charge and mass, they are, for example, mass of alpha particle will be 4 times unified mass unit, and charge of alpha particle will be 2 times of the elementary charge. So if we write charge on the alpha particle, it would be 2 times 1.6 into 10 power minus 19 coulombs, and the answer would be 3.2 into 10 power minus 19 coulombs. So if we want to calculate VP and VS, VP will be equal to, it's a positive charge, alpha particle, it would be plus 1 over 4 pi epsilon naught charge of alpha particle divided by distance of P from the alpha particle. Now, if we substitute the values, it would become 8.99 into 10 power 9. Charge of alpha particle is 3.2 into 10 power minus 19 coulombs, and distance of P from the alpha particle is, as you see, it is 20 into 10 power minus 9. Now, the answer of this calculation would be, let me use calculator for this. Now, this is as you see, 8.99 into 10 power 9 multiplied with 3.2 into 10 power minus 19, and this is divided by 20 into 10 power minus 9, and the answer that we are getting is 0.143 volts. So potential at point P is 0.1343 volts. Now, in the same manner, we can calculate the potential at point S. Vs will be, since alpha particle is a positive charge, so potential due to alpha particle will have a positive sign, so it would be plus 1 over 4 pi epsilon naught charge of alpha particle divided by, one second, charge of alpha particle distance of S from the alpha particle. So it would be plus 8.99 into 10 power 9 into charge of alpha particle is 3.2 into 10 power minus 19. This 8.99 is basically the value of the constant. 1 over 4 pi epsilon naught. Epsilon naught is a constant given in the exam. It is 1 over 4 pi into 8.85 into 10 power minus 12. Now, if you calculate it as a whole, it is 8.99 into 10 power 9. So this is Coulomb's constant as a whole. Now, divided by distance of S from the alpha particle is 30 nanometers. So it is 30 into 10 power minus 9. So the overall answer of this calculation will be, it will become 8.99 into 10 power 9 multiplied with 3.2 into 10 power minus 19 divided by 30 into 10 power minus 9. So this will give 0.0. If we write it up to three significant figures, so it would be 0.095. It is 89, we can write it as 9 and volts. So we calculated the potential at point P and potential at point S. Now onwards, the important thing is the potential of the 2 points, point S and point P. Potential at point P, which is closer to the alpha particle, is 0.143 volts, and potential at point S, which is away from the alpha particle, is, as you see, 0.0959 volts. Now these are the potentials of these 2 points. Now let's solve B part of the question. A proton has to move from S to P. What should be the minimum speed of the proton so that it must be able to what should be the minimum speed of the proton? What should be the minimum speed of the proton at S? What should be the minimum speed of the proton at S so that it must be able to reach P? Now this is a typical question about calculating the minimum speed of a particle so that it should be able to reach a certain point. So basically we need just enough speed of proton at S so that it should be able to reach P. Here you have to observe one thing. When the proton is moving from S to P, it is moving towards high potential or low potential. Potential of point S is 0.0959 volts, and as you see, potential of point P is 0.143 volts. Now a proton, when it moves from S to P, it is moving from low potential to high potential. S is relatively negative as it is at low potential, P is relatively positive as it is at high potential, and you see proton is a positive charge. So a positive charge is moving towards high potential. What will be the direction of force? It is opposite to the motion. Now electric work will be negative. Proton is gaining potential energy, but at the cost of kinetic energy. The proton have to decelerate. It will lose kinetic energy and it is gaining potential energy. And in the questions of electric field, we assume the system of charges to be isolated. So the basic idea here is we only assume to be the electric force to be acting. So the electric force is the only force and that is the resultant force. That's why the force is decelerating and hence the proton is undergoing a deceleration. Now this proton is moving towards high potential and it needs energy to overcome the repulsion. Now the question is basically what should be the minimum energy that the proton must have at point S so that it should be able to reach point P. Now let's calculate that. Now for example, you have to calculate the minimum value of U minimum at S so that the proton should be able to reach P, obviously with no kinetic energy. Because when the kinetic energy is just enough to reach P, at P the speed and kinetic energy will be zero. In other words, whenever you have to calculate the minimum initial speed, then the final speed is taken to be zero. This will always apply. Now in this example, first of all, we should write, in your exam, you will only write the answer, but right now we are focusing on the concept. So we should say that the motion of the proton is opposite to the electric force. The motion of the proton is opposite to the electric force, so it is gaining electrical PE and losing kinetic energy. Now we will apply conservation of energy, like we'll say that Ke lost will be equal to, we are equating the magnitudes. Ke lost will be equal to electrical PE gained. When we equate the loss and gain of energy, we have to focus on one thing. We have to keep both the sides as positive. For example, the Ke lost will be equal to initial Ke will be bigger. So we'll say Ke1 minus Ke2 must be equal to P is gained, so Pe2 minus Pe1. So loss of Ke will be equal to gain of Ke. So loss of Ke will be equal to gain of Pe. So we should write it as 1 over 2 mu square minus 1 over 2 mv square is equal to Q times V2 minus Q times V1. So we are doing this to keep both the sides positive because we cannot equate loss and gain because loss is negative and gain is positive. Loss of energy will have a negative sign. Gain of energy will have a positive sign and we cannot equate both of them. Now, if we substitute the values, it will become 1 over 2 mu square minus 0 is equal to Q times the final point is Vp. So Q times Vp minus Q times Vs. Now let's substitute the values. 1 over 2 into mass of proton is given in the exam on the first page in constants. 1.67 into 10 power minus 27 into u square is equal to charge of electron. Charge of proton is 1.6 into 10 power minus 19. Potential of point P is obviously 0.143 minus 1.6 into 10 power minus 19 into potential of point S is 0.0959. 0.0959. Now, if we solve this, it will become 1 over 2 into 1.67 into 10 power minus 27 u square is equal to 1.6 into 10 power minus 19 into 0.143 minus 0.0959. Now, if we calculate the right hand side, it will be 1.6 into 10 power minus 19 multiplied with 0.143 minus 0.0959. So the answer that we are getting, it is 7.54 into 10 power minus 21, and this is in joules obviously. Now u square will be equal to 7.54 into 10 power minus 21 into 2 divided by 1.67 into 10 power minus 27, and this will become into 2 and divided by 1.67 into 10 power minus 27, and the answer that we're getting is this is u square is equal to, it is 9.025 into 10 power 1, 2, 3, 4, 5, 6 into 10 power 6 meter square per second square. I'm using the calculator on my cell phone, so please re-verify the answer. However, the concept is correct. So if we take under root on the two sides, since we are calculating the speed, no need to put a plus minus. So under root of answer will be, it is 3.0. It is 3004 basically meter per second. So this is the answer for speed that we are getting. This should be the initial minimum speed for the proton so that it should be able to reach point P starting from point S. Basically, proton is moving towards repulsion, so it is decelerating. So it needs some energy to overcome the repulsion. So initially, we have to provide kinetic energy to the proton so that it could overcome the repulsion and it could move towards point P. Now, last part of the question. This was part B. Part A, we are done with part A, we are done with part B. Now, C part is the last part. Why cannot you solve part B using conservation of energy? The question here is, why is it not possible to solve B part of the question using conservation of energy? And the answer for this part is, we cannot solve it using conservation of energy because conservation, no, it can be solved using conservation of energy, using equation of motion. We solved it using conservation of energy. The question was, I'm sorry about that. Why cannot you solve B using equations of motion? Like, why cannot you apply equations of motion on the given question? One of the equations of motion is, for example, 2as is equal to v square minus u square. Why not this equation? The answer to this part is the electric force, and hence the acceleration is variable, so equations of motion cannot be applied with equations of motion cannot be applied with variable acceleration. So since the acceleration is variable, so equations of motion cannot be applied. Now let's move on some more examples. Now we'll start from the given values of potential. For example, you're given with point X and point Y. Potential of point X was negative 0.021 volts. Potential of point Y was negative 0.5 volts. The question is, an electron starts with a rest from X. What will be its speed when it will reach Y? What will be the speed of electron when it will reach Y? This is the question here. So to solve this question, we have to apply the method. Now, first of all, you have to understand it is electron, which is a negative charge. So electron is moving from X and it is going towards Y. Now, out of X and Y, which has low potential? Potential is a scalar. Sign will be counted in comparison. So potential of X, that is negative 0.021 volt, is smaller, no, in fact bigger. It's a scalar, so sign will count. So if the value is smaller and negative, then actually it is bigger. Is bigger than negative 0.5 volt. So negative 0.02 volt is bigger than negative 0.5 volt. As a result, now we'll think about that as X is relatively positive and Y is relatively negative, because X is, as you see, X is less negative and Y is more negative. So the one that is more negative will be taken as negative, and the one that is less negative will be taken as positive. So we can say that X is less negative. So X will be given a positive sign and Y will be given a negative sign. And I think the question should be changed. It should start from the other point. For example, electron starts from rest with Y and it is moving. What will be its speed at X? The question should be other way around, because the values of potential suggest that X is positive. So please change the question. Electron starts with rest from Y. What would be its speed at X? Because X is a relatively positive point and Y is a relatively negative point. So electron is moving from Y to X. So basically this is Y, this is X. And the question is about motion of electron from Y to X, not from X to Y, because it has to accelerate. Y itself is a negative point, X itself is a positive point, and the electron is moving from Y to X. This is the motion of the electron. And this motion, the electron is accelerating. Force is in the direction of motion. However, the force could be variable or it could be constant. Since it's not given, so equations of motion should be avoided. This question will be solved using conservation of energy. Motion is in the direction of electric force. Motion is in the direction of electric force. So electric work is positive and electrical PE will decrease. Electric work is positive, so electrical PE will decrease. And as you see, potential at Y is negative 0.5 volt. Potential at X is, as you see, negative 0.021 volt. X is at high potential, so it is relatively positive. Now, electron is losing potential energy. So the formula would be gain of Ke by electron will be equal to loss of electrical PE. Now, whenever you apply conservation of energy, focus on one thing. The equation must have same signs of two sides. So you should write bigger minus smaller on the two sides. If kinetic energy is gained, then the final will be bigger, 1 over 2 mv square, bigger Ke minus smaller Ke. Potential energy is lost, so the initial would be bigger. So Q times V1 minus Q times V2. So 1 over 2 mv square minus 1 over 2 mu square. It will be Q times V1 is actually Vy and V2 is actually Vx. Now we have to solve this because if the electrical PE, no, we should calculate, this is negative charge, this will not apply. This concept will not apply here because we have negative charge here. So instead of doing this, we should just write it as delta PE. And first we should calculate delta PE, that is a wise approach, and then we should put it here. So first let's calculate delta PE. Delta PE is Q times delta V. Now delta V will be equal to V2 minus V1. That will be equal to, and we are going to ignore the sign. V2 is Vx, V1 is Vy. So delta V is Vx minus Vy. Vx is negative 0.021. Vy is negative 0.5. So the answer of this part will become negative 0.21 minus, in fact, plus 0.5, and the answer is 0.29. So this is 0.29 volts. And even if it would have been negative, we would have ignored the sign. So delta PE, we calculate delta PE as a magnitude. Charge of electron into delta V between the points which are, I think, X and Y. So charge of electron is 1.6 into 10 power minus 19 coulombs. And the difference of potential is 0.29 volts. And the answer here would be 1.6 into 10 power minus 19 into 0.29. So 0.29 into 1.6 into 10 power minus 19. And the answer of this calculation is 4.64 into 10 power minus 20 and joules. Now we will substitute this value in the previous formula of delta PE, that is 1 over 2 mv square minus 1 over 2 mu square is equal to 4.64 into 10 power minus 20. So 1 over 2 into u is 0, so it will become 1 over 2 into mass of, it was electron which is moving particle, I think. Yes, it is electron. So 1 over 2 into me into v square, and starting speed was 0 into 10 power minus 20. So the answer of this part will be 1 over 2 into mass of electron is 9.11 into 10 power minus 31 into v square, and it will become 4.64 into 10 power minus 20. So v will be equal to under root of 4.64 into 10 power minus 20 into 2 divided by 9.11 into 10 power minus 31. Now, if we substitute these values, it would become under root of 4.64 into 10 power minus 20 into 2 and divided by 9.11 into 10 power minus 31. Now, the answer of this calculation is speed is equal to 3.19 into 10 power 1, 2, 3, 4, 5 into 10 power 5 meter per second. This is the speed gained by the electron in this movement. Now, one last example about conservation of energy, and then we'll move to the next topic. One last example about conservation of energy. It is, you're given with 2 points. One of the points is P, the other point is Q. P is at negative 2 volt, Q is at negative 10 volt. Now, A part of the question, mark positive and negative on P and Q. So if we compare the potentials, negative 2 volt is bigger than negative 10 volt. Potential is a scalar. If the sign is negative, then the smaller magnitude will be bigger. So Vp is bigger than Vq, hence Vp is a positive point and Vq is a negative point. So P is a positive point, Q is a negative point. High potential is positive, low potential is negative. This is part A. Now part B. So an electron has to move from P to Q. So basically the electron is moving towards repulsion. An electron has to move from P to Q. What should be its minimum speed at P so that it must be able to reach Q. Now in this motion of the electron is moving towards the negative point, and this motion of the electron is facing a repulsive force. The force is against the motion. So because of this repulsive force, the electric work will be negative. Electrical P will increase, but at the cost of obviously kinetic energy. Here the question is, what should be the minimum speed at P for the electron so that it should be just enough to reach Q. When you have to calculate the minimum speed or just enough speed, you have to keep the final speed to be 0. So V is 0 and U minimum is to be calculated. So as a result, the formula here will become The electron is gaining potential energy, so we'll say loss of kinetic energy is equal to gain of electrical potential energy. Before moving on, we should calculate the change of potential energy or the gain of potential energy. Delta PE will be equal to Q times delta V. And if we want to calculate delta V, it will be equal to V2 minus V1. So the final point is Q, the initial point is P. So VQ minus VP, and the sign in the final step will be ignored. So you see VQ is negative 10 and VP is negative 2. VP is negative 2. So the answer of this part will be negative 10 plus 2. So it would be negative 8 volt. But we have to calculate delta PE as a magnitude. So as a result, delta PE will be equal to charge of the moving particle, which is electron here. Magnitude of charge of electron should be multiplied with magnitude of delta P between QP. And the answer to this part will be 1.6 into 10 power minus 19 coulomb. It will be multiplied with 8 volts. So answer of this part will become, if we make this calculation, it would be 1.6 into 10 power minus 19, and this will be multiplied with 8 volts. And the answer would be 1.28 into 10 power minus 18, and this is joules. Now, if we apply formula that the electron is moving against the repulsion, and obviously it is losing kinetic energy, so we'll say loss of KE will be equal to gain of PE. In case of loss, the initial value will be bigger, so it is 1 over 2 mu minimum square minus 1 over 2 mv square is equal to gain of P is 1.28 into 10 power minus 18. So we'll have to keep both the sides as positive so that we can equate them. It would become 1 over 2 into mass of electron into U minimum square minus the final speed will be 0 because we have to calculate just enough speed. So it is plus 1.28 into 10 power minus 18. The answer to this part will become 1 over 2 times mass of electron into U minimum square. Now let's substitute the values. It will become 1 over 2 into mass of electron is 9.11 into 10 power minus 31, and this will be multiplied with U minimum square, and this will be equal to plus 1.28 into 10 power minus 18. So U minimum will be equal to 1.28 into 10 power minus 18 into 2 divided by 9.11 into 10 power minus 31. We will take an under root because of the square. So answer will be under root of, it is 1.28 into 10 power minus 18 into it is 2, and this will be divided by 9.11 into 10 power minus 31. So the answer will be the minimum speed here. What we'll get is 1.67 into 10 power 1, 2, 3, 4, 5, 6. So 1.67 into 10 power 6, and the unit will be meters per second. So this is the minimum value of speed that we are achieving for the electron that is moving between these 2 points. Students, these were some examples about conservation of energy. Next slide will be about potential gradient and then graph of electric field. 2 more slides are remaining. Okay, students, take care. Khuda Hafiz.